Support for today's Heat Treat Radio episode is provided by Nel Hydrogen Ebook, Hydrogen Generation and its Benefits for Heat Treaters. Get this Heat Treat Today resource for free at www.heattreattoday.com/ebook. Welcome to Heat Treat Radio. Doug Glenn, publisher of Heat Treat Today, and today's guest, Bill Disler, president of AFC-Holcroft, are exploring salt quenching. Why is there a growing interest? Is it better than oil, water, or gas? What are the costs? And how is it green? Let's jump in.
First time, welcome to Heat Treat Radio.
Thank you very much, Doug.
Yeah, that's good to have you. It's about time. We got here.
It's been a little while. Sorry.
That's good. Bill, as I mentioned, I'm pretty sure it's your first time on Heat Treat Radio, but it is. You've written several articles for us, all of which have been very well received. So we appreciate that. But if you don't mind, give our listeners just a brief introduction to yourself and your history in the heat treat industry.
Sure. I started out in heat treat actually back in 1987. And so I've been in the industry for quite a while. I came out of college with an electrical engineering and math computer science degree, and ended up working at Holcroft back then. And after a short period of time as an electrical engineer, I ended up over in China helping debug some systems, control systems, which my 6-week stint turned into 2 years. So it kind of gave me a jump start with some appreciation hands-on with furnaces and building furnaces, pushers, continuous, and batch and rotaries. And over the years, I've done quite a few different things, from managing an advanced controls group, estimating sales, and had a little stint outside of heat treat with a German company called Dur when Holcroft was going through some ownership transitions. And that gave me a little bit of a nice perspective, I think, outside of heat treat. So when I came back to AFC-Holcroft after they acquired Holcroft, it kind of had opened my eyes to some things. And I love the heat treat world, but we're not always the fastest moving with technology. So that gave me a little bit of an insight with what the automation lines for building engine blocks and heads and things were all about. Along the way, I was president of ALD-Holcroft, which was a joint venture between ALD, the German vacuum carburizing group, which gave me a lot of insight into a different form of process where we're mainly atmosphere and they're vacuum carburizing and gas quench. And, all the way through the journey, somehow I ended up in the corner office at AFC-Holcroft. But I'm still an engineer and probably a little bit of a sales guy at heart, I think.
Yeah. How long as the president of AFC-Holcroft?
Okay, that's a good question. I think it's been about 8 years now, I think. 8-9 years. It was, so we, from before we went through the transition with the acquisition into the Icoline Group, which happened in July of 16, which is already almost 5 years, I guess. So in several years before that.
Yeah, good. And out of Wixom, Michigan, for those who don't know. Yes. Detroit area, which is great.
We have plenty of global entities and partners, but a home base for engineering team and myself is Wixom, Michigan.
Yeah.
Not too far from where Holcroft started in downtown Detroit in 1916.
Yeah, exactly. Yeah. Very, very good. All right. So let's just jump into our topic today. We're going to talk about quenching. Heat Treat Today has done a lot of different articles on various types of quenching. Most of them have been focusing in on either high pressure gas quenching, oil quenching, maybe some polymer water type quenching. We're going to talk today primarily about salt quenching. Okay. But if you don't mind, give us just the 30,000 foot view on some of those more chic, popular, newer type of quenching, if you would, please.
Well, quenching is obviously for our customers in our listening group. I assume, one of the most critical things in a lot of our heat treat processes. So, since I've been involved in heat treat, which has been a few years, there's always been focus on different types of medias to quench in. And over the years, I guess I've come to look at quenching as a fairly basic thermal heat transfer process. So I guess as we talk about salt eventually, we can talk maybe about some of the other processes and some of the fundamentals that people maybe don't always understand about, say, oil or, which frankly, we and the general population of people that carburize and quench, generally it's oil that's the common quenching. Still far and away the most popular from anything else out there. And, oil is a very flexible quenchant. It's tried and true. It's predictable, but it does have one challenge. And I think this kind of ties into the evolution into gas quenching. And the challenge with oil is it boils. So as you take a hot part, put it into oil, the reason we all focus on quench agitation, not too much speed, not too little, it's to try to take the oil past the part before it forms, before it boils.
Yeah, before the vapor
reality
stage.
Is, yeah, you just can't do that.
Right.
You can help it, but there's always going to be a vapor phase. And the challenge with that is the non-even heating of heat transfer into a liquid versus heat transfer into a gas is significantly different. So you've got two phases basically with oil that you're quenching the parts into. And what's probably the most common concern with quenching? It's distortion.
Yes.
So over time, I think that's really the introduction of gas quench. So the evolution of trying to control distortion is really, I think, mainly from oil, a two-phase, I'll call it a two-phase quench, where you have liquid heat transfer and a gaseous heat transfer taking place to a single-phase quench.
Right.
So when you compress gas, it's already in a gaseous phase. So if you get into, say, an 18-bar quench, the higher the pressure, the better the heat transfer. But it's a single-phase quench, which means generally you don't have that big differential in temperature when you're quenching parts, so your distortion tends to improve. The challenge with gas quenching is that even at higher pressures, 18-bar or reasonable pressures, in a cold chamber, going from a hot chamber to a cold chamber quench, like on the larger systems that are used in some of the automotive gears, the heat transfer coefficient is still not very good. So you're just not able to take enough heat away fast. So that was really the big evolution and introduction, I think, of gas quenching, which I tend to talk about separate from vacuum carburizing. But the gas quench element was all about distortion control. And transmission gears in the automotive, they were hoping to go from oil quench, where they had to get the distortion and hard grind them, very expensive. They wanted to go to gas quench, and then they wouldn't have to grind. The reality is generally they still grind today, but the gas is a better heat transfer media when it comes to distortion than oil because it's single phase. It just can't take a lot of heat out fast. And I think, that's where we're seeing salt come back into the picture, even for martensitic type quenches. So if we look at that evolution, we go from oil, then they go to gas quench for distortion. But now a lot of the challenges I think people are seeing is that the heat transfer rate limitations, you've got to go to very light trays, maybe carbon fiber fixtures, things like this. It's got its limitations. And also for certain parts, they could be just too thick to take the heat away quick enough to be successful. The other big thing is it's not cheap. You've got very complex high pressure chambers with 300 horse motors and so on.
You're right. Yeah. You're sucking down the electricity. We know that for sure with the high horsepower motors typically. Yeah.
And unfortunately they tend to they have to cycle. So in a big plant, it's one thing having a lot of power consumption, but it's another thing where you have these high speed, these high horsepower motors starting and stopping all the time. Not usually things that our customers like. But hey, clearly it's an acceptable heat transfer quench system, and for the right set of parts, it can be a very good fit. I think that we've kind of gone through an evolution where a lot of customers went from one type of quenching into this, and we're seeing a lot more activity with them saying, "Wow, we really like the distortion control, but what else is there?" Which is where salt starts coming back into the mix.
Right. Which is what we really want to talk about. I think that's probably a good segue, Bill. to get over into it. I mean, salt quenching, what is it? What is it? I don't know that a lot of people use it. So just explain it for the uninformed. What's a salt quench?
I think if the minute we typically talk about salt, and a lot of people I've known in the heat treat industry for a long time, I bring up salt. What are you talking about salt? That's nasty stuff. We don't want to use that. So first, I guess I should start out saying we're talking about salt quenching. Okay. Historically, when people talked about salt, maybe we'll talk about this a little bit later, they talked about high temperature salts as well that had cyanide and things like this in it. Nasty animals.
For salt bath heat treating, basically is how you're heating it up, but we're not talking about that.
We're not talking about that. We're talking about using conventional atmosphere equipment and then quenching instead of oil or polymer or something else or gas, taking it into molten salt. And I'd say that in general, the most common thoughts with salt is to use it for bayonetic quenching. So if you're quenching into a bayonetic structure, salt has always been the only way to do this. And the reason is you can take it up into the temperatures where you form bayonet, which is, I'll say, often 600-700 degrees Fahrenheit, where they're using salt to quench into a bayonetic structure versus martensite, which is a lot of our conventional heat treat. So I'll call it a bit of a specialized process, but it's very common. So all your spring steels, there's a ton of parts that are bayonetically quenched. And in general, you'll see a lot of mesh belts doing stamped parts.
Yes.
In a molten salt. Most of those are into bayonet. Spring clips, retaining clips, things like that. And but you also have batch systems that have the ability to quench into salt type environments. And still, I'd say the majority are into bayonetic quench. But what we're seeing the growth into and much more activity is martensitic quenching. So I'll just say transmission gears, for the sake of an example. What people might not realize, and I'll be, I guess, appropriate in not naming the company, but one of the big three in the day, American Automotive Company, prior to going to gas quenching, vacuum carburizing, all of their transmission gears were quenched into salt.
And salt quenched, okay?
Salt quenched. Rows and rows of pusher furnaces into salt quench to get martensite.
Okay.
So the benefit of that they saw, and I'll say these lines were built in the 70s and the 60s. So this isn't new. They were using molten salt to get martensitic quenching in transmission gears because it was less distortion than oil.
Okay.
So then their evolution was to go into, with some of the German dual clutch transmissions came gas quenching. And interestingly enough, some of those folks are now saying, wow, that was really expensive. I've got this equipment for 10 plus years, and maybe I should revisit some of the other stuff that used to give us the same distortion in martensitic. And so this is, I think, the journey that salt has gone through. It is not a new process. It's been around for a lot longer than I've been in the business. But it does have a stigma of dirty, which is I think maybe unfair. And if it's confused with high temperature salts, then it has an environmentally unfriendly feel to it.
Right. Well, we'll talk. I want to talk about that. I want to talk about the greenness, quote unquote, of it here in just a second. But let's talk about. So you've given us a sense of it that it's been around for quite a while. Salt quenching. But let's talk about some of the advantages.
To me, sometimes it's easier for somebody to kind of be able to visualize what's happening in a quench, and then these pieces fall into place. So if you consider, let's say you use the example of parts with significantly different thicknesses. They can be challenging for any kind of quench media. But, the big thing that causes distortion and can cause different problems is the vapor phase of oil. So if we're going to compare to oil. So if you think about the things that happen when you get a vapor film or some bubbling on the surface of a part, it's all about uneven heat transfer. And I use the example of, if you want to take something out of your freezer and thaw it, you sit it on your kitchen counter in the air, and how long will it take to thaw, or put it in some water?
Yeah.
It's a radical difference in heat transfer between a gas and a liquid. And this is really what happens when you get a film boiling with oil. So we do a lot of things to minimize that. That's quench agitation. But if you have a big, thick piece of material here and a thin piece here, this is going to give up its heat really quick. This one may not. You got to get into the core that you're still taking heat out. So there's a heat transfer rate, and I'd say that salt at a quenching temperature of maybe 350 degrees is going to have about the same heat transfer rate as oil. We'll just say roughly. So it's not about heat transfer as much as the fact that it's all uniformly cool. So even if the heat transfer coefficients of oil versus salt were similar, the reality is, in a quench, that you're not getting the liquid heat transfer rate in oil in all aspects of the part.
That's right. Yeah.
And so those areas cool much slower, where salt won't boil. That's the key. Salt doesn't boil in the temperatures we're dealing with. So it's always a liquid heat transfer rate.
Right. So in a sense, with oil, you think you're dumping it into a liquid, but the fact of the matter is, for some fractions of a second or fractions of a minute, you actually have a gas quench going on there, if you will, because of the vapor, right? I mean, you've got an insulating layer there that's preventing the liquid from actually hitting the metal. So you're getting ununiform quenching. And
you could look at this from let's say you've got a ring gear or something, and you're like everybody's got flow of oil coming to the bottom. So you might be getting nice liquid quench, liquid heat transfer here, but what's on the other side, where you have a little bit less flow, and you've got a bigger vapor barrier on that side, and guess what? That's what makes the gear bend. So the key is here, whether or not you're talking about a gas quench or a salt quench, the characteristics of the quenchant are the same. They're single phase.
Right.
And that brings a huge amount of benefits in heat transfer. And you could talk about something like a blind hole. Really hard to quench a blind hole.
Yeah, that was a question, actually. Yeah.
Okay, so as an example, it's hard to carburize or quench a blind hole. That's one thing. Say, for instance, in a blind hole, I'd say a good argument for vacuum carburizing. If that's a big issue, you need to carburize inside of it, because vacuum carburizing can probably get inside more than endo. But when it comes to quenching, they're hard to get into either way. But imagine oil getting into a hole that's very hot. What's going to happen? You're going to get boiling in that hole. So I'm not saying that salt's going to cure all those problems, but you don't have it boiling trying to get into the hole. You still got to get the fluid in the hole, which is a problem. But you don't have the vapor that's pushing it back out. So in those cases, it's very much a case by case. But I think that just the physics of salt, and if people can visualize what's happening when you're quenching, this is it's not magic. It's just that it's a single phase quench. And that brings a lot of benefits. And it's a single phase quench with much better heat transfer rates than, say, 18 bar nitrogen. So this is where you can use it in places where you can't gas quench a part. You got a thicker part and you just can't get the heat out of it in a gas quench. You may very well be able to get the distortion benefits from salt, but still get the heat transfer rate that you need to quench out the part.
One of the things you mentioned, Bill, was with oil was the reason that you engage in a lot of the stirring of the quench, the agitation and things of that sort, is to help keep that, to hopefully eliminate the vapor stage, keep the oil flowing over the part. So that helps with the distortion. Do you have to do the same thing agitation wise with salt, or do you do the same thing with salt? Do you agitate to quench as well?
Yeah, we still want to be moving the salt past the parts. So just like any media. And it's not as much a worry about boiling, but you're still transferring heat into the salt. So you want to take that heat and move it away from the parts. So agitation is the vehicle to do that. And that gives you, because you were talking about uniformity before, the tank uniformity of a salt quench versus an oil quench, it's all about the same. I mean, we can hold uniformity throughout.
Okay.
The bigger thing is instantaneous temperature rise with a quench, which is a different topic, which is just really a function of the volume of the tank.
Yeah.
But the agitation, I'd say, we still want to move. In most cases, it's not as sensitive. If you're in a mesh belt where you're dropping parts down through a tank, you might not need that agitation. But in a batch or a fixtured continuous load, we definitely would want to still agitate the salt through.
Primarily just to keep the cooler salt, if you will, cooler salt coming by, which therefore can increase your heat exchange or heat extraction.
Yeah, your heat transfer rate would stay constant because you've got the same temperature salt through it. Yeah.
You know what? I got one other quick question though. I just thought of it. What oil quench runs typically at what temperature? What temperature do you keep the oil quench bath, and what temperature do you keep the salt quench? Are they roughly the same?
No, they can be significantly different. It depends on lots of things, but I'll say we'll typically see oil running from 120, 150 degrees Fahrenheit up to 350 degrees Fahrenheit.
Okay.
In fact, we've had customers run over 400 degrees Fahrenheit with special oil, but generally you're up into the flash point of the oil, and it's not really a great idea. And those are all Martin-Seta quenches. Remember, oil can't get you bainite. It can't go high enough in temperature to get a bayonetic quench. So if you're quenching it to bainite in salt, which is still very common, you're up in the, you're above the Martensite start point for materials, which is, of course, it depends on the alloying of the material. Call it 400 degrees Fahrenheit, rough figure, maybe 350 degrees Fahrenheit. So above those temperatures, salts are very comfortable, and they'll run up to 800 degrees is really no practical limit, but there's no need to go much higher than that for bainite. If you wanted to get into Martin-Seta quenches, you're going to be down around the 300 degree temperatures. You can't go to lower temperatures with salt. So probably your realistic lower point would be about 300 degrees, which is, I tell anybody looking at it, you really got to look at your parts, your alloy, and everything else to make sure it's still a fit. But in most cases, that can get people what they're looking for. It's not a one size fits all. But
no, right. And that was kind of one of my questions, was just how low can you go? Kind of like limbo here, right? How low can we go with salts?
You could hardly go down to maybe 250, but the lower temperature salts don't behave that well. So I'd say probably in the 300 degree range, 350. And that's also probably for a customer that's looking to optimize distortion control. As long as they can get the hardenability at those temperatures of their materials and so on, that's probably the sweet point for trying to minimize distortion. But it's always a balancing act here, because you're still at a temperature that's higher than some of the colder oils. So there could be some parts you simply may still not be a great fit, but that's why we have to look at them on a case by case.
Right. Yeah. I mean, and just another thought that jumps to mind is that you don't have a flash point with salt, I assume.
Not in the temperatures we're working with.
Yeah.
We'll be returning to Bill and Doug after a short break to hear about green practices associated with salt quenching. Now, we're all wondering where to quickly learn in-depth knowledge about new heat treat technologies. Some will say heat treat radio. Others will point to industry journals or specific videos on Vimeo or YouTube. But if you want curated information that you can skim or study with accompanying visuals and illustrations to really get across those points, read the free ebook, Hydrogen Generation and Its Benefit for Heat Treaters. This ebook is easy to access, it's free, it's on Heat Treat Today, and it's written by experts at Nel Hydrogen. You can download it anywhere, anytime. It's packed in 18 pages with pros and cons of on-site generation, including cost, sourcing, and furnace types, OSHA EPA compliance, and so much more. Hydrogen generation and its benefit for heat treaters is free to download at www.heattreattoday.com/ebook. That's it. Let's get back to the episode.
Is salt quenching green?
Yeah, and as we said before, I think that the first reaction of the average listener when I say yes is like, that guy doesn't know what he's talking about. We're dealing with sodium nitrite salts. I won't go so far to say it's exactly what your table salt is, but it's not that different. There's no cyanide in it. There's no nasties in it. And depending on where you are, small quantities can probably go down the drain. Some places not. You're not going to dump a bunch down, obviously. But it is not like oil. The other big thing that's very important is that in the current systems, we reclaim close to 99% of the salt.
Okay.
So as you quench, if you look at an oil quench, you go into an oil quench, you come out, you wash the oil off, and it ends up in a washer, kind of messy, homogenized, and we have skimmers of various types, and then you get this sludge that you have to get rid of. With salt, you'll come out of the quench with some liquid salt on it. You'll go into a washer, but that salt then dissolves back into the water. So generally, there's a multi-phase wash with a wash, rinse, rinse. And then after we get a certain percentage of salt in the wash solution, we thermally evaporate the water off, leaving the salt back where it can be reintroduced into the quench tank. So when you look at it from that standpoint, salt's reclaimed. Oil, the oil, unless you're really getting into high-tech thermal recovery for oil, that just it's a not friendly to get rid of. And the other thing is, you're recycling your salt. You got to load it up once, but you don't have the life expectancy problems typically with salt. You can rejuvenate it. You can mix your balances over time. And oil, yeah, you can recycle oil, do additives, but if somebody's really picky about their heat treat, after a year or two, you better be dumping the oil and starting all over again. And where does that oil go? It's contaminated oil. So from an environmentally friendly standpoint, ironic as it sounds to some people, salt is a very, very green process. We recycle almost all of it.
Yeah. On site too. It sounds like when you're recycling or reusing it, you're able to do most of that on site. Whereas a lot of people are sending oils out, right? I mean, they got oils out, get them tested, all that good stuff.
Yeah, this is all on site. So you have a recovery system, whether or not it's a batch or a continuous type operation, you can recover the salt. And so from an environmental standpoint, it's much greener. And so we're trying to let people know that because, there's a lot of movement to environmentally friendly heat treat. Whether or not we start seeing more electric furnaces or not, we'll see. Carbon footprint gets looked at, but Quenching's one of them that this has a bad rap.
Yeah. Well, they were talking about, I was watching the other day on one of a little industry thing about the first batch of completely green steel was delivered to a car company and manufactured, or maybe it was a off-road vehicle company, Caterpillar or somebody like that, where they made their first fully green piece of equipment from green steel that came from somebody. So we'll see. But you're right. The point being, green is here, Green is here. And, I'd say that's a bit of the benefit, I would say, over oil to gas quench as well. I think we'll be seeing more, traditionally there's, all of the people in the furnace manufacturing world will soon be delivering carbon footprint data on our furnace information and so on. A lot of our customers are already looking for that. And it's already here in Europe, but it's coming to the US as well. And it's interesting as we start comparing, our experience with LPC and gas quench, there's also electricity. Now we're tracking to where you're making the electricity. If it's from a coal plant or a natural gas plant, there's still a carbon footprint to it. So I think as we
as we unravel these complicated topics, it'll be interesting to see our preliminary information, how well conventional atmosphere and something like salt fares in that comparison. It's interesting, but people forget, even with vacuum furnaces, which we've built quite a few of, they're water cooled.
Yeah.
Water cooling and pumping water through stuff that you have to put additives in and everything else is not environmentally friendly. So the irony is, over my career in atmosphere furnaces, there's been an ongoing push to get all the water off of the furnace. There used to be water cooled fans, water cooled door frames. I don't want any of that now. And we're all air cooled, and even our endo generators. And then here you go in this new environmentally green system, and you're pumping tons of water around. And so as we've started doing some comparisons with salt, oil, and all the other systems that we offer, it is coming out interesting what's really green and what the perception's been out there.
Right. Yeah. Yeah. Well, I think that's generally true for most of the green movement. Is what's perceived to be green and what might really be green is a different thing.
Yeah.
If you read in our August issue, we had a column by Lorenzo Goncalves, who's the chairman, president, CEO of Cleveland Cliffs, and he had very interesting things to say about what people think is green and what really is green. So it's
a very interesting topic and sensitive one, but we'll be hearing more about it, I'm sure.
Yeah. Well, I just want to, on a completely serious note here now, when I graduated from high school in 1980, our class song was Kermit Frog singing "It Ain't Easy Being Green." Well, now we know it isn't easy. Actually, most companies will tell you it's not so easy. So Kermit had something there, man ahead of his time. But okay, so I got one environmental question for you about the salt quenching. Is how about the work environment around salt? Is it is there off gassing? Is there anything workers near it? I mean, if you work near a salt bath furnace, forget it, come in with a face mask on, but how about salt quenching?
No, I think really, to be objective, there's from a salt standpoint, if you walked into, we've got an Ostemper heat treat that's just belt Ostempering up here in the Detroit area. If you walk into that plant, it's incredibly clean.
Okay.
You don't have the oil fumes and vapors and things like that, which in any plant, if it's properly, vented and so on, isn't a big deal, but you don't have that kind of a feel to it. So there's nothing toxic about it. But it's like any other quenching. If you're operating oil or salt at 300 degrees or above, you got to take care. None of, whether or not it's oil or salt, they don't mix well with water because it's above the boiling point of water, as an example. So I'd say in those areas, those two have similar challenges. It's just a matter of dealing with a hotter quenching. The one challenge I'd say with salt, and these are, I'll say, the conventional, a bit older equipment, is that the carryout, when you carry out salt that's molten, when it cools down, it solidifies.
On the surface.
Instead of getting a little grease or oil on your transfers, you could get solidified salt. It's not fun or desirable. So with salt, if you're in a batch line, for instance, it's more pronounced, and you do have to have some special maintenance procedures to rinse down your transfer car and things like this. As long as you do that, it's very easy to maintain. But the reality is you're coming out of a hot quench, and when you get it onto a transfer car to get to a washer, it can solidify.
Yeah.
Once you get to the washer, then it's easy street. In your continuous furnaces, it's really not an issue because you're going right from one area right into a washer, and it's much more contained. But the reality is, your batch systems can get a bit messier. And if you're then taking, say, a hot load that was quenched to a bayonetic temperature and putting it into a washer, you could be putting a 600 degree Fahrenheit load into a washer, and you get a lot of steam.
Yeah.
And the challenge is, if you don't contain the steam can contain salt in the vapor. just like really oil can be in vapor too. So, but it's just a different animal. And you really don't want that any more than you want an oil vapor. It can stick on different things. And the one thing that, I'd say that'd be the one reality about salt with batch. The newer systems and things that we focused on is overcoming that. For instance, by quenching in salt, if it's not batch, moving directly into a multi-stage washer before that load even comes out onto a transfer. So there's no carry out of salt. So by the time the parts come out, they're perfectly clean. And the nice thing is, remember, washing salt off of a part with water versus washing oil off with water. Another big topic, maybe you've had some podcasts on, is washing oil.
Yeah,
right?
We've had some washing. Yeah, you bet.
You know that story that oil and water don't mix? Well, they don't. However, salt and water do mix. Salt goes into solution in water, and we carry it away, and you're going to get nice, clean parts. So that's another nice byproduct of a system designed properly. In the older days of those old big pusher furnaces, I said one of the automotive companies was making transmission gears. Those were open salt tanks. So we come out of a furnace into an open salt tank, and then you bring it up and take it into the washer and the temper. And along the way, you had all kinds of salt buildup. But remember, those were about 50 years old. So the key is designing equipment to manage it differently, containing those wash fumes and things like that. That's really what we see the next evolution of salt quench systems being, because we do see salt becoming more common, frequently asked for after the people have had their interest with compressed gas quenching and distortion control. Now that it's coming back, we really need to think about repackaging it to keep it clean in the plant.
All right. So, Bill, how about with every quench system, with every system, whatever it is, there's maintenance involved. Any special maintenance requirements on a salt quenching system?
Yes, I'd say it's different than a conventional oil quench system, and I would say any quench system that you're looking at has its uniquenesses to maintenance. Salt can be something that needs to be learned a bit if it's new to somebody. We talked a little bit about the risk of salt solidifying and creating a mess that you'd have to rinse it down. So as I said, in a transfer car, in a batch situation, we normally would suggest a parking station where you can rinse that car down very easy. So you do have to look for salt buildup on some of the systems, and not difficult maintenance, but you have to be attentive to it. The one thing that's I'll say a benefit with salt or oil in some cases, when you have carry out, it gets all over your equipment. It's a lubricant.
Yeah.
So it's messy, it's undesirable, but it's a lubricant until a bunch of other crap gets tied into it, and then it can be an abrasive lubricant. But salt doesn't bring you that benefit. So you have a little bit more housekeeping, a lot of recommendations of how to do that. Also, generally for a quench system, we would recommend a holding tank that you can pump out the tank with. Versus maybe some plants would use a tanker or have a company come in and pump out tanks. The reason for that is if you had maintenance or if you had a different issue, you want to try to keep that salt liquid. So when you're looking at things, if you were running a heat treat where you really wanted to shut it down for extended periods of time and bring it back up and so on, you have to look closely at salt, because salt doesn't, it takes a while to re-liquefy once it solidifies. It's not the kind of thing you turn on and off, like one of the benefits of a gas quench. You turn it on and off. So again, everything, there's no one size fits all. It's got a blend of benefits and some challenges. So it just depends on the operation itself.
Is there danger in a salt quench system if power goes out and the salt solidifies? I mean, are you going to ruin your equipment, or is it just, it froze up, now I gotta heat it back up?
I'd say the worst case scenario is, again, we would recommend then pumping it into another tank. But if in fact it were to solidify, you just have to take the time to remelt it when you get power back.
Okay. It's not like it's not like ice. I assume it doesn't expand.
It's not going to blow
tank.
up or yeah. It's no.
Okay. All right. That's good. All right. Let's move into a little practical question about applications. So, I've got it's kind of a two-part question. First, what are some typical applications for salt quenching? And then secondly, are there products and or processes that people are doing that they really ought not even think about salt quenching? So first, what are the good ones? Secondly, what are the ones we shouldn't think about?
Again, I guess I take salt quench applications into two categories. The most common that we talked about earlier are bayonetic quenches, os tempering and things. We even see it now becoming more common, ductile iron os tempering, which is a slightly different process, starting with a different material. The benefit of that, and we'll see more and more of it, is it's got a tremendous strength to weight ratio, even better than aluminum, as an example. So it's a great way to lightweight certain things. So we have the whole world of bayonetic quenching, which is pretty traditional with salt. But I'll say the less traditional would be the martensitic type quenching. So we'll say more conventional to most of our people using oil. So applications for that, I think, one thing that we're seeing a lot of activity is in gears. The reason for gears being, something that people are looking close at, because they're so sensitive to distortion. And, again, even when people went to gas quench, they found that to get quiet enough transmissions, they still did some light grinding. But just to be clear, the less distortion you have, the less grinding you do. Grinding isn't a nice process. It's you're grinding away on some hard steel. So I think that's something, especially when we look at electric vehicles coming out. Some of those powertrains are now spinning at much higher RPMs. Distortion is going to be even more sensitive to them, and I suspect that salt could play a role for them, especially in some of the volumes, if they don't want to get into some of the complications and expenses of a gas quench type system. Right.
Okay. All right, good. And how about people that really don't even think about salt if you're doing this type of product?
Well, again, I think part of it is it's the application itself. You've got to, getting into salt, if you're already in oil, is a commitment. So, there's a lot of benefits to it. I would say, there's going to be some parts where maybe you can't get the heat transfer quenching down to 300 degrees. If you need to be in a cold oil, a lower temperature quench to get certain characteristics, salt's probably not going to be a great fit for you. There are interesting things happening now with salt that's maybe worth mentioning, and it's been going on for a while. But interestingly enough, we talk about vapor barriers and all this stuff. There are some people that add small amounts of water to salt. And interestingly enough, AFC-Holcroft's been doing a lot of research on this, because the actual physics of how this works is kind of mystifying. Even for os tempering ductile iron, when you've got salt at 600-700 degrees Fahrenheit, there's water often added to the salt to increase its quench severity. So the question you obviously ask is, well, how the heck do you get water to stay in salt?
Yeah, anything over 212.
Yeah. So it does in fact happen, and it stays in a liquid form based on some testing we've done. Whether or not it's a combination of the pressure and there's some other physics going on. But the interesting thing is, when we did testing with the heat transfer rate, it's not just conventional water blend with salt to give you the heat transfer coefficient change with salt with a little bit of water in it, but it appears that as you do quench and there's water, it's the latent energy that is needed to transfer the water into gas, which is a little bit of something we're trying to work against, right? That absorbs a lot more energy out of the material. So we know that water is a very severe quenchant.
Yes, right.
So it can really change the quench severity of salt with we're talking about 1% to 3% water in salt. And we just recently, AFC-Holcroft got a patent on a quench severity probe, which can actually measure that in salt. So whereas before there was no way to measure that, we can actually now with the probe see the change in quench severity with this technique within a quench tank, so that it's more repeatable. But I guess it's a complicated topic. If people want to follow up and ask me some questions about it later on, I'm happy to talk about it.
Yeah, well, so I wanted to follow. So you guys patented this quench severity probe?
Yes, we got a patent.
So I see another heat treat radio in your future. Okay.
We've got a few patents. I don't talk a lot about them, but we've got some interesting things going on. But that was one that we started working on a couple of years ago because people for a long time added water to salt to change the quench severity, but it's a very difficult thing to measure. So now being able to look at means to measure it in situ is potentially an important ingredient in the next years for people that start transferring into this as a more viable quench option.
Gotcha. One other question, real quick. This might be taken back just a little bit, but maybe a very brief answer. The parts that come out of a salt quench compared to the parts that come out of a high pressure gas quench, how about the cosmetics of them?
They're not going to be as bright and shiny as coming out of a gas quench. I don't think there's anything out there right now that's going to give you the same cosmetics as gas quench. If you have an application where that's really important, gas quench is hard to beat. I will tell you that what's interesting is there's pros and cons to that. First of all, the vast majority of parts that are gas quenched, gears as an example, still go through a shot peening process. And that's not for cleanliness, it's for surface strength and
right, compressive strength, compressive surface.
Yeah, and the other thing is it's as we're working with AFC-Holcroft, a lot of these systems now have to actually etch the parts coming out of heat treat. Because the benefit of nice clean parts, they're nice and clean. The downside when you're managing a captive or a commercial heat treat is you can't tell a green part from a hard part. And believe me, there's been some nightmares where that didn't go well. Yeah, and they all look the same. So ironically, for all the benefits that has, it added in our lines when we were doing, in the gas quenching systems, etching the part so that you could tell. But it's still not a perfect scenario. So again, if you need nice clean parts, salt's not going to give you bright and shiny.
Right. Okay. All right. Fair enough. So last question. If I'm a captive heat treater, currently using oil, currently using high pressure gas quench, what are the questions I ought to be asking myself about potentially transitioning back over to salt? How do I know my process is a good candidate?
Well, I guess that's a good question. I think, there's ways we can look at a particular material, the type of part. And the big thing first is, can we get the heat transfer rate to get the hardenability at the temperatures that salt is able to quench at? So, if you vet a part through that process, you could then, look at maybe doing some testing and so on with distortion and so on. So I think, if you could be a candidate for a hotter oil quench with your part, this is probably quite viable. If you really need to get into cold oil with the heat transfer rates there, it's worth doing some testing, only because, again, sometimes you don't know exactly what the true heat transfer rate you're getting with oil is, because it could be, that vapor phase playing a little bit of a game with you. So even though the textbook heat transfer rate of salt isn't quite as good as it would be for an oil quench in that situation, it might bring benefits beyond just those static numbers. So we probably need to do some testing and things like that. The big thing I guess I will say, and it's not a plus to salt, but I'm here to be objective. We build all kinds of equipment, not just salt quench. So we're just talking about salt. The one thing that I'd say a captive or a commercial needs to look at, and it depends. It's also a factor with the design of the equipment. we've been in a lot of heat treats, Doug, I'm sure. And some of them you go in there and, you want to make sure you don't have your leather-soled shoes on because, everything's got a film of grease on it or oil. The one thing that we tell customers that if you're going to put in salt, it's better if you can have it in an area separate from your oil quenches. And the reason is that depending on the system, you can still get vapor if you don't vent, say, a washer real well. You won't get it off of the quench because it never boils. It's generally the washer. And I'd say that in the older days, we had, you'd see the steam coming out of a washer. It looked like, like a leaky tea kettle boiling over, Those systems, you've got to be careful because there's salt residue in that vapor. Mixing salt residue with oil isn't a good combination. And the reason is oil will burn. It's got the carbon in it. Salt is an oxidizer. So you really don't want those two mixed because it can burn more aggressively and be, create more of a danger. So I would say in a real, one of the hurdles to people looking at salt is that it's not easy to just put in any old heat treat. If you got a big oil quench line, old heat treat, sticking a salt line right next to it, we probably wouldn't advocate that.
No, it's such a good idea.
Just, I'll say the newer equipment we're coming out with, we've got a new product that's been developed to kind of address that specifically to contain any salt vapor. But the risk that people should look at is mixing salt and oil. If either one of them are allowed to go into vapor phase, you don't want those two vapors condensating together because the salt can be your oxidizer to oil, which wants to burn. So, just for the safety's sake, we would advocate trying to do this in a separate area, which can be a huge hurdle to a lot of people.
Sure. All right. Very good. Very good. So, Bill, I'm guessing there's going to be some people potentially wanting to get a hold of you with questions. And of course, they can always touch base with us at Heat Treat Today. But whatever you're comfortable giving out, if people want to get in touch with you directly, what can they do?
No, I'm happy to provide some information. I think it doesn't take long to look on the internet to find my contact email if you needed to out there. So, I'm available at W Disler. William Disler, so WDISLER at AFC-Holcroft.com. And if you send questions to me, I can direct you. If either myself, I can address it, or our sales team or an engineering person can follow up. Also, I've got an office line that I'm happy to give. You can call 248-668-4022. That's an office line that then can get directed to different people too. Or, of course, go online. You can grab AFC-Holcroft's main line. And we're doing, you'd be surprised how much salt equipment is being ordered these days. People would probably be surprised. It could be, I don't know if it's quite yet half of our volume, but it's a good 30%, and it's a growing segment. So we've got a lot of people very familiar with it. Plus, we do operate two small heat treats that do belt os tempering only. So the Keogh family that eventually was AFC, Atmosphere Furnace Company, then acquired Holcroft, their roots sit with salt. And so there's a lot of heritage and knowledge within our group to help people with any questions. And I can direct you to the right people that can answer those for you.
Good. All right. That's great. So people interested in getting a hold of Bill, you can do W for William Disler, DISLER at AFC-Holcroft.com or office phone 248-668-4022. Bill, thanks a lot. Appreciate your time. Interesting topic, salt quench. We'll have to just stir up a little interest in this. So,
well, I appreciate the chance. Sorry, I've been dodging in and out of the shadows here. It's one of the rare fall days that has sunlight in Michigan.
Yeah, I was going to say, listen, let's not complain, right? I mean, we recorded this on November 8th, and most of the leaves are still on the trees and the sun's shining. So there's no complaining here.
I'm not complaining at all. But thank you very much for having me on your show. And it's an interesting topic that we'll be seeing more of in the future. So I hope I was able to answer some questions and spark some interest in some of the people out there.
Very enlightening. Very, very salty. Very good job. Yeah.
Thanks a lot,
All
Doug.
right, Bill. Thank you.
We hope you enjoy listening to today's episode with Bill Disler. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with Bill, head over to wdisler at AFC-Holcroft.com or call him at 248-668-4022. You can also email me and I can put you in touch. My email is bethany@heattreattoday.com. We're always looking for new, interesting topics to talk about on the show, so if you have an idea for a future episode or if you'd like to sponsor a future episode, let me know and we'll be in touch. Again, my email is bethany@heattreattoday.com. Also, check out some of the other resources that Heat Treat Today has to offer to keep you prepared for your next sales call, system upgrades, or trade show events. Aside from the podcast, heattreattoday.com has technical articles, video content, a consultants page, and a resource calendar, all targeted to serve heat treaters. Check out any of these periodically as we continue to update the website daily. Heat Treat Radio would like to thank the Nell Hydrogen Ebook, Hydrogen Generation and its Benefits for Heat Treaters, for sponsoring this episode. Learn about the pros, cons, costs, and more at www.heattreattoday.com/ebook. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Our outstanding audio and visual producer, Jonathan Lloyd, created and mixed most of the music that you heard today. Check out his professional work at www.jonathanlloydmusic.com. Thank you, Jonathan. And I'm Bethany Leon. Thank you for listening.